ever pondered if time travel could become more than just a plot in science fiction novels? Time travel, a concept that has captivated our minds and fired our imaginations for centuries. It's a staple of pop culture, gracing the pages of countless books, the screens of numerous movies, and the plots of innumerable TV shows. From H.G. Wells' The Time Machine to the futuristic escapades of Doctor Who, we've immersed ourselves in fantastic tales of hopping through time. These stories, while often fantastical, are rooted in our deep-seated curiosity about the universe and our place within it. We're fascinated by the idea of bending the laws of physics to our will, of stepping outside the relentless march of time. The possibility of witnessing the past firsthand or exploring the unknown future is an alluring prospect. Imagine if we could hop into a spaceship, travel across the universe, and return to find centuries have passed on Earth. But could this fantastical idea ever morph into reality? Can science lend credence to these wild musings? Well, let's delve into the realm of Einstein's theory of relativity. This revolutionary concept, proposed in the early 20th century, fundamentally changed our understanding of space and time. It presented the universe not as a static entity, but as an elastic fabric that could be warped and stretched by matter and energy. Now, the theory of relativity includes two key principles: the special relativity and the general relativity. The special relativity posits that the laws of physics are the same in all inertial frames, and that the speed of light is constant, regardless of the speed of the observer. This has a peculiar implication: time dilation. Time dilation, a mind-bending phenomenon, suggests that time can speed up or slow down depending on the speed of an object or its proximity to a gravitational field. In other words, time is not absolute, but relative. A clock moving at high speeds or placed near a massive object would tick slower than a stationary one in a weaker gravitational field. This is why astronauts aboard the International Space Station, moving at high speeds around the Earth, age slower than us by a fraction of a second. So, what does this mean for time travel? Theoretically, if we could travel at speeds close to light or venture near an extremely massive object, we could slow down time relative to others. This could allow us to leap forward in time. However, going back in time poses a greater challenge and remains a contentious topic among scientists. The general relativity further complicates the picture by predicting the existence of wormholes, shortcuts through space-time that could potentially allow for backward time travel. But that's a topic for another scene. So, while we can't jump into a DeLorean and travel back to the 1950s, the theory of relativity suggests time travel isn't entirely out of reach. However, there's another intriguing concept that could potentially allow for interstellar time travel: wormholes. Let's delve into the fascinating world of wormholes, shall we? Imagine a tunnel, not through land or sea, but through the very fabric of the universe itself. This is the essence of a wormhole. It's a theoretical passage, a shortcut, if you will, through the dimensions of space and time. The idea of wormholes isn't just a product of wild imagination, though. It's rooted in the equations of Albert Einstein's theory of general relativity. These equations describe the fundamental forces of our universe, and within them, they suggest the possibility of bridges or tunnels between different points in space-time. Now, why are wormholes significant in time travel? Well, space and time are intrinsically linked, forming a four-dimensional structure known as space-time. When we talk about moving through space, we're also talking about moving through time. Wormholes, in theory, could twist and bend this space-time fabric, creating a shortcut between two distant points. Think of it like folding a piece of paper in half. If you were an ant crawling from one end of the paper to the other, it would take a long time. But if the paper is folded, bringing the two ends together, you could quickly step from one end to the other. That's essentially how a wormhole would work. It's like folding space-time to bring distant points closer together. Of course, this is all purely theoretical at this stage. Despite their presence in Einstein's equations, we've yet to find any concrete evidence of wormholes. They remain elusive, hiding in the mathematical shadows of our understanding of the universe. In essence, wormholes could be our cosmic shortcuts, bending the fabric of space-time to connect two distant points. They're like cosmic backdoors, offering us a glimpse into the possibilities of interstellar time travel. Who knows, one day, with advancements in our understanding of the universe, we might just find a way to open these doors and step through. But how would these cosmic shortcuts work exactly? To answer this, we need to dive a little deeper into the mind-bending mechanics of wormholes. At the heart of it all is a strange and elusive substance known as exotic matter. Now, don't let the name fool you. This isn't some fantastical substance from a science fiction novel. Exotic matter is a theoretical concept within the realm of quantum physics. What makes it exotic is its negative energy density and large negative pressure, characteristics that defy our everyday understanding of how matter should behave. According to Einstein's field equations, this negative energy density could, in theory, prevent a wormhole from collapsing under its own gravity. In other words, exotic matter could prop open a wormhole and make it traversable. But here's the catch. We have no definitive proof that exotic matter exists. It's a theoretical concept, one that's necessary to make the mathematics of wormholes work out. But it remains unproven. Even if we were to find exotic matter and successfully prop open a wormhole, there are still significant challenges and dangers associated with traversing these cosmic shortcuts. The interior of a wormhole is predicted to be a region of intense gravitational forces. These forces could easily crush or stretch anything that ventures inside. Moreover, the journey through a wormhole might not be a smooth ride. Theoretical physicists predict that wormholes could be unstable, fluctuating and changing shape in unpredictable ways. Imagine trying to navigate a tunnel that's constantly shifting around you. Not exactly a walk in the park, is it? Then there's the issue of radiation. High levels of radiation could be present inside a wormhole, posing a significant risk to any potential travelers. In summary, while wormholes present an enticing prospect for interstellar travel, the reality is far more complex and fraught with danger. The journey through a wormhole, hence, might be as perilous as it is exciting. So, what does this all mean for the future of interstellar travel? Well, if wormholes are indeed a reality, they could revolutionize the way we explore the cosmos. Imagine for a moment a universe where distances once deemed insurmountable could be traversed in the blink of an eye. A world where reaching distant galaxies is not a question of if, but when. This is the tantalizing potential that wormholes present. However, like all things in science, there are hurdles to overcome. Currently, our understanding of wormholes is largely theoretical. Despite the exciting possibilities they present, we are still in the early stages of comprehending their complexities. For instance, how do we create a wormhole? And once created, how do we ensure it remains stable? These are questions that continue to challenge the brightest minds in the field. Despite these limitations, research in this area is far from stagnant. Scientists across the globe are tirelessly working on unlocking the mysteries of wormholes. With advancements in technologies such as quantum computing and artificial intelligence, we are inching closer to answers every day. Each discovery, each breakthrough brings us one step closer to realizing the dream of interstellar travel. The journey is long and the path is fraught with challenges. But, as history has shown us, human ingenuity knows no bounds. Just as we once thought flight was impossible, we may one day look back at our current understanding of space travel and marvel at how far we've come. The future of interstellar travel is an exciting, albeit uncertain one. It's a future filled with the promise of exploration, discovery, and perhaps a deeper understanding of our place in the universe. As we continue to push the boundaries of what's possible, who knows what incredible revelations await us on the other side of the wormhole? While our understanding of wormholes and time travel remains largely theoretical, the possibilities they present continue to mesmerize us. Time travel and wormholes, it's a lot to wrap your head around, isn't it? We've journeyed through the enigma of time travel, dived deep into the science behind it, and introduced the concept of wormholes. We've tried to simplify the complex mechanics of wormholes and looked into the future of interstellar travel. Yes, it's a lot, but it's also incredibly fascinating. The concept of time travel, once a mere figment of science fiction, could become a reality. Wormholes, those mysterious shortcuts through the fabric of space-time, hold the potential to revolutionize our understanding of the universe. The future of interstellar travel is a realm of endless possibilities. As we continue to push the boundaries of our knowledge and technology, who knows what we might discover? So, the next time you gaze up at the night sky, remember, the possibilities are as infinite as the universe